In the 16th century, Flemish physician Andreas Vesalius described how a suffocating animal could be kept alive by inserting a tube into its trachea and blowing air to inflate its lungs. In 1555, this procedure didn't warrant much acclaim, but today, Vesalius's treatise is recognized as the first description of mechanical ventilation, a crucial practice in modern medicine. To appreciate the value of ventilation, we need to understand how the respiratory system works. We breathe by contracting our diaphragms, which expands our chest cavities. This allows air to be drawn in, inflating the alveoli, millions of small sacs inside our lungs. Each of these tiny balloons is surrounded by a mesh of blood-filled capillaries. This blood absorbs oxygen from the inflated alveoli and leaves behind carbon dioxide. When the diaphragm is relaxed, the CO2 is exhaled alongside a mix of oxygen and other gases. When our respiratory systems are working correctly, this process happens automatically. But the respiratory system can be interrupted by a variety of conditions. Sleep apnea stops diaphragm muscles from contracting. Asthma can lead to inflamed airways, which obstruct oxygen. And pneumonia, often triggered by bacterial or viral infections, attacks the alveoli themselves. Invading pathogens kill lung cells, triggering an immune response that can cause lethal inflammation and fluid buildup. All these situations render the lungs unable to function normally. But mechanical ventilators take over the process, getting oxygen into the body when the respiratory system cannot. These machines can bypass constricted airways and deliver highly oxygenated air to help damaged lungs diffuse more oxygen. There are two main ways ventilators can work: pumping air into the patient's lungs through positive pressure ventilation, or allowing air to be passively drawn in through negative pressure ventilation. In the late 19th century, ventilation techniques largely focused on negative pressure, which closely approximates natural breathing and provides an even distribution of air in the lungs. To achieve this, doctors created a tight seal around the patient's body, either by enclosing them in a wooden box or a specially sealed room. Air was then pumped out of the chamber, decreasing air pressure and allowing the patient's chest cavity to expand more easily. In 1928, doctors developed a portable metal device with pumps powered by an electric motor. This machine, known as the iron lung, became a fixture in hospitals through the mid-20th century. However, even the most compact negative pressure designs heavily restricted a patient's movement and obstructed access for caregivers. This led hospitals in the 1960s to shift towards positive pressure ventilation. For milder cases, this can be done non-invasively. Often, a face mask is fitted over the mouth and nose and filled with pressurized air, which moves into the patient's airway. But more severe circumstances require a device that takes over the entire breathing process. A tube is inserted into the patient's trachea to pump air directly into the lungs, with a series of valves and branching pipes forming a circuit for inhalation and exhalation. In most modern ventilators, an embedded computer system allows for monitoring the patient's breathing and adjusting the airflow. These machines aren't used as a standard treatment, but rather as a last resort. Enduring this influx of pressurized air requires heavy sedation, and repeated ventilation can cause long-term lung damage. But in extreme situations, ventilators can be the difference between life and death. And events like the COVID-19 pandemic have shown that they're even more essential than we thought. Because current models are bulky, expensive, and require extensive training to operate, most hospitals only have a few in supply. This may be enough under normal circumstances, but during emergencies, this limited cash is stretched thin. The world urgently needs more low-cost and portable ventilators, as well as a faster means of producing and distributing this life-saving technology.
في مجالات